Q.
Sure. Hello everyone, I am Dr. Ghulam Hussain and today I will talk about the structure and age of the earth. So we can take a look on this figure first. This is actually the view of earth from the moon, and we can see this is the view of earth from the moon, and this actually is Earthrise is a photograph of earth, and some of the moon's surface that was taken actually taken from the lunar orbit, by the astronaut William Andrews on December 24th, 1968, during the Apollo mission actually. Then we also know that this photograph actually is very famous, and we don't know about the surface of the earth and how does it looks like inside. But today in this talk, actually we will discuss about how our earth looks inside. Okay, let's talk about the content slide first. Okay, so here are the few contents what I'm going to talk today about this topic, and actually these contents are from this book. You can see I got the book like the chapter 8.10. Okay, so first of all we will talk about what do we know about the earth, and then we will also detailed description. We will know the detailed description about the inside the earth, and then we will discuss about some of the changing ideas and how ideas are developed with respect to the time. And then we will talk about the tectonic plate ideas, and then later we will talk about the age of the earth, because then we know that the geologists how discover the earth's age, and then how they measure the age of the earth, and then later we will have activity 8.10 according to the book. Okay, and then finally I will summarize my talk. Okay, so first of all we are going to take a look on what do we know about the earth. So you can see here we have first of all earth, and then Mars, Mercury, and then Venus. Actually these all the human perceptions have changed with respect to the time, and we all know that the early history about the planets as moving lights. But you know, in 1600th century, first telescope saw the hazy spheres. But today it's a complex system. So today we are looking for every system, not only the solar system, but today we also know a little bit about the Earth's inside, and then also about the other planet systems. So we know these four pairs planet system. So scientists already have hypothesized likely origins of the solar system actually. So in that solar system, the Earth is also one of that. Okay, so let's talk about what do we know about the Earth. And still continuing. So geologists actually have worked out that the Earth is about 4500 million years old, like 4500 million years old. Then you know, in the content slide I already told you that we will measure this. The scientists will define the age, will estimate the age of the Earth, right? And then they also worked out how the Earth is like inside, because we are every day we are walking on the Earth, but we don't know what's going inside. So Earth has a different surfaces, but we also have the detailed description of the Earth's interior. Okay, let's take a look on the brief introduction about the Earth. So in this we have also the radiometric age dating, and then we can see the spontaneous change and decay, and then we also have the half-life. Actually, you know why we are talking about this radiometric age dating? The reason is that in this radiometric age dating, we have a lot of radioisotopes. So this Earth is made of a lot of radioisotopes. Especially, you can talk about the uranium, right? Uranium, potassium, right? And also the thorium. So there are a lot of radioactive isotopes. These isotopes decay spontaneously, and some of them, you know, they are changing with respect to time, and they also have the half-life. Even the half-life is nearly to the Earth's life. Okay, so the study of the process, actually geology have studied the process they create the Earth's feature and the search for clues about the Earth's history. You can say Earth's early history. So this is that what geologists have worked on it for a long time. So they already discovered that the Earth is almost so much old. Like you can say is 4,500 million years old, and then corresponding to we have a lot of radiometric age dating, because we can consider some like meteoroids. Meteoroids can estimate the age of the Earth. Okay, so let's take a look on the some compositional layers of the Earth. Okay, so what are the main compositional layers of the Earth? So what layer actually consisted? We walk every day on the Earth, but we don't know what's going on inside the Earth, right? So actually Earth have different structures and different composition. We will take a look on the detail. We will take a look on the detail wise, like the Earth structure. Okay, so here we are. Okay, so we know that we can divide Earth into crust, mantle and core. And then here you can see the core is the right inside of the center of the Earth, and then mantle a little bit outer, and the crust we walk on it, right? Okay, so now we are going to understand for the each part why we have core, mantle, crust, and what kind of material is inside there, right? What kind of composition is there? Okay, so first of all we will see the Earth's interior here. So you can see this is Earth's interior, and the Earth's interior is divided like the inner core, and then we have an outer core. Okay, then followed by the mantle, and then followed by the crust. Okay, so first of all we will take a look on core. Okay, so core actually is made of iron and nickel, right? And then the inner core is a completely solid, but the outer core is a kind of a liquid. Okay, so core actually is composed of the two major parts. So in these two major parts, the core is very dense and composed mostly of iron and nickel actually. And then the inner core is solid. The inner core is solid. This is because there is so much pressure exerted that it can only exist in the solid form. And then we can talk about little bit about the outer core. What is outer core here? You can see here the outer core. The outer core is a liquid iron and nickel again. It is very dense, but because it's in the liquid form, it is less dense than solid and forms the outer core, because it's this one is less dense. That's why it is in the liquid form. Okay. Now we will need to talk about the next one. That's a mantle. Okay, let's talk about the mantle. We know the mantle is right here, and then we can talk about the mantle. So you can see here the mantle is the less dense area, less dense than core. So mantle is composed of iron, magnesium silicates, right? It is mostly solid, right? It's mostly solid, but the uppermost part of the mantle is partially molten slush, where you do have liquids and solid mixed. Now this is very important in the plate tectonics. Actually, the mantle is very important for the plate tectonics. Actually, we will talk about the plate tectonics later in the coming slides. Okay, let's take a look on the later part of the crust. Okay, so actually the crust is the outermost layer of the Earth is a solid rock, right? So it's a continental, and also it's made of the granite. And then lastly we have a oceanic basalt. So we know that the crust is different, that is a continental crust, but on the besides that we also have an oceanic crust. Okay. Let's talk about a little bit more about the crust. Why crust is like that? Actually, the crust is the outermost layer of the Earth. Actually, we can see this is the outermost layer of the Earth, and then it's the same like that. You have an apple, right? And then apple is very hard from the inside, but outside there is a peel, right? So you peel off, and then you will eat an apple. Okay, so the crust is behaving like a skin of an apple. Actually, this is the outer skin, you see, right? Okay. Now let's talk about the changing ideas. So with respect time, the peoples change their ideas about the earth, what kind of ideas they have changed. So we can see here, so people used to think that earth was only a few thousand years old, but it doesn't like that. You remember at the starting of that, at the starting of what do we know about the earth? We talked about that the earth is 4,500 million years old, but here is just 1,000 years old. So the people change their ideas with respect time. Okay, and they thought that the earth never changed. So they already thought that the earth never changed, but it doesn't like that. Actually, earth is changing with respect to time. We can also see in the coming videos. Okay, so now we will have a continental drift problem here. So continental drift model problem actually is suggested by a very famous scientist. So is Alfred Wegener. Alfred Wegener, 1912. Alfred Wegener, he was a German scientist, and he suggested that million years ago all the land was a one large continent. So he suggested that all the land is just one part. So, but it doesn't like that. He presented his research to the professionals because he is a scientist. So he presented his research to the all over the world, but they didn't accept because he didn't provide the plausible mechanism to explain how continents drifted actually. So when Wegener actually presented his research to the other physicists, they didn't agree. They wanted to know the mechanism to support the continental drift. So Wegener couldn't answer how. So his continental drift was not accepted. So his continental drift was rejected actually. So we all know that this is the continental drift model problem. So this is still continuing, and we know the shapes of the continents fit together. And then these ideas are given by him, and we know these are the different continents here. So we can also see that how the continents were joined a long time ago. So here we can see the types of the rocks on the different continents match up where they fit together. So all these rocks, all these continents where they fit together, so they can fit together and they match, okay, and they become like different continents. And then the second one is, the last point is that the fossils on the different continents, match up where they fit together. Okay, this is actually very interesting. Actually, this is the drift model problem is just all about the Wegener's theory. Okay, so now we have actually the tectonic plate ideas. So beyond that, we will have a tectonic plate ideas. In 1960, a new theory of the tectonic plate was developed. Okay, we can see here the different plates, right? So you can also see the edge of the tectonic plates. So the theory is that the Earth's surface is made up of a large plates actually. Okay, so the tectonic plate is still continuing. In this tectonic plate, these plates move slowly on the molten magma actually, and molten magma underneath them. And we can see here all these tectonic plates are here from the different almost 16 to 90, and then we have a molten magma here. And then later we will see how these plates move slowly in each year. We will see in the different browser, we will see how these tectonic plates are moved over the time. Okay, let's take a look on this browser to see the volcanoes and the earthquake zones. Okay, first of all, I would like to explain the molten magma. What is actually the molten magma? So the molten magma is tectonic plate ideas is still continue. So we know that these plates move slowly on the molten magma underneath them. But you know these tectonic plates, and we know this is the molten magma pictures actually. So before that, we need to understand what is actually the molten magma. So you know the molten magma is a molten and a semi-molten rock mixture found under the surface of the earth. So found under the surface of the earth, this mixture is usually of 4 parts: a hot liquid base called the melt, minerals crystallized by the melt, solid rocks incorporated into the melt from the surrounding confines and dissolve these gases, And these plates move, these plates move only a few centimeters each year. I would like to show you some other graphics from my video. You can see how the plates are moved actually slowly. So stay there. So we can see here, this is the time, this is the million years, right? And then we can see how the time is the changing, and then the tectonic plates are changing. It's actually it's a start from the today. I can go back and you will see here. You will see here. So this is the today's Earth. Actually, it's a picture of the North America. So you can see here then how like the million years, after the million years, the tectonic plates are moving slowly. Okay, so please take a look on the video. So you see how these plates are moving slowly. The time is changing here with respect. The tectonic plates are moving slowly. So actually this unit is a million years. So each year have the different era, right? It starts from the today. Thank you very much. Okay, so then again back to the PPT. So I would like to show you the last bullet on this. You see here, I said here, open the browser for the volcanoes and the earthquake zones. So I will show you, except this, we already take a look on how the tectonic plates are moving around. Now we will see how these volcanoes and the earthquake zone surrounding the earth. Okay, let's take a look on. Okay, here we are. So you can see here. So first of all, you will take a look on the different boundaries. So you can see the different boundaries on the earth, and these all are called plates, right? So this division has been already done in the different plates. Like this is the Eurasian plate. So the part of China is in the Eurasian plates, and some of the part like in the different plate like Taiwan. Like I'm also from Pakistan, so this is also the Eurasian plate, right? So and then we will see the different volcanoes. See here. So these red dots actually is these red cones. Actually, this red one is showing you the different volcano zones on all over the earth in the different tectonic plates. Okay, with that one, I think I'm going to uncheck the volcanoes, and then we can see the earthquake zones. You see, now these are black dots. You see, these black dots have a different earthquake zones all over the world. And later, in your questions, you will have a question to answer. What is the relation between the tectonic plates and the earthquake zones? Okay, I think this is a very interesting slide. So you can also see here the different details. You may take this from me to understand. Okay, and you will also see how this velocity is using to move these tectonic plates from the different plates to the another plate. These plates are slowly moving from one side to another side. You see, there are different directions. See. Okay. Now back to the PPT. Okay, so I think we already understand the volcano zones and the earthquake zones. Let us continue our PPT. Okay, so We also have the tectonic plate ideas still continue, so these plates move slowly, right? And then we done this slide actually. I am going to move on the next slide. Okay, so the next slide is pretty clear. So this is actually the age of the earth. How scientists have worked for many years to know the age of the earth. So you see this graphics, you can see this picture actually is 4.28 billion years ago. So you know these stones, or you can say the rocks, these rocks actually are very old, right? And then you know scientists can use the proportions of different substances in rock to work out how long ago the rocks were formed. So scientists, you know, they know they can work out. You know, I remember at the starting I said the radioactive dating, right? So the radioactive can also tell us whether because you know the rocks are decaying with respect to the time, right? So the scientists already found the oldest rock was discovered like 4.28 billion years ago. So you can see these are actually is the Canadian based these actually is in Canada. Okay, let's take a look on further slide about the age of the earth. Just understand few more points. Okay, so the age of the earth, actually it is difficult to find the rocks that are the same age as the earth, because you know the rocks are continuously decaying, right? They are decaying with respect to the time, so they are changing due to the half-life, right? So they are decaying continuously. And scientists believe that the earth was formed at the same time as the rest of the solar system was developed, right? So when the solar system was formed, the earth was also formed at the same time. So now the final question is how to measure this, how to measure the age of the earth. Let's take a look on this. So we have a word meteors. So to help them, we help the scientists to help them discover the age of the earth. So they study like the different rocks from the moon and from the meteors. So a meteor is a fragment of the rocks from space that falls to the earth. Actually, this is these graphics is all from the book. You can also take a look in the book, The Age of the Earth, right? So the graphics are also given there. Okay, so you know we have a rock from the space that falls to the earth. You know, in our solar system, and also there are many galaxies. There are small, you know, a lot of things every day fall on our earth, right? So scientists have found meteors that are 4.5 billion years old, right? And they think the earth is the same age as these meteors. And we also have some fragments of the Canine Diablo meteors which fell in the Arizona, USA. Okay. So now let's take a look on the activity. What activity we need to do that? You guys actually need to do that. So actually we have learned a lot about the age of the earth, right, and the different ideas and the tectonic plate ideas about the earth. Okay, so you know here these reference books you can use. You can use internet to find out how scientists believe the earth was formed, right? And then remember to include some of the evidence for their ideas. So you can search on the internet for the different ideas the people have researched a lot. And then present your findings as a report, a poster, or a talk to me. And then you can also find the journals or papers from this website archive. And you can also even find my previous geology paper also there. So I have worked on the geoneutrinos. Okay. So before the summary, I would like to show you another video which is actually the complete video about this the structure and age of the earth. Okay, let's take a look on together. Okay.
Planet Earth is the home of every life form known to us in the universe. Its age is about a third of the age of the universe, and, admit it, it is a thing of beauty. A slightly scorched sphere with a heavy metal core.
So we actually have this video. I have developed like a different. You can see the different subtitles, Chinese and English, and you can completely understand this video actually.
An unlighter surface crust wrapped in a thin sliver of sweet air to breathe, with vast oceans, fertile plains, magnificent streams, lakes and aquifers, orbiting a star which warms us and gives us energy. But how did our home come into existence, and what's it made of? 4.6 billion years ago, Earth was created from the remnants of dead stars that collected in a giant dirty gas cloud. The gas cloud became denser in its center and formed an accretion disk. Small particles started clumping together.
So I think we already talked about how this Earth is formed, right? So how the Earth is formed and the rest of the solar planet systems are how was formed, right? So we believe that, and the scientists also believe that both the Earth and the other planets were formed at the same time. Okay, enjoy this video, the rest of the video.
And building larger and larger objects until they form the objects we call planets today. This process took 10 to 20 million years and is still not very well understood. At about this time, when the solar system was young and chaotic, a giant object about as big as Mars collided with our home. The impact was violent, and if the object had been more massive, it might have destroyed Earth. Material from Earth was smashed out into orbit and formed the Moon, which is the biggest satellite in relation to its planet in the solar system. At this time, Earth was a hot hell, constantly being hit by asteroids, with seas of lava and a toxic atmosphere. But something was about to change drastically. Earth cooled down. Water from the inside of the Earth wandered to the surface and rained down on Earth, only to vaporize again and become clouds. Millions of asteroids brought more and more water to our planet. All the water on Earth has about this volume compared to Earth. Today, the surface of Earth is 71% water and 29% land. 97.5% is saline water, while only 2.5% is fresh water. The fresh water is 69% ice and snow, 30% are groundwaters, and only about 1% make up the remaining groundwaters. But even this small part is mostly frozen. Only a tiny part of our water is actually lakes and rivers, and an even tinier part is bound in living things. So, gradually the Earth cooled down, and the surface formed a thin crust. But inside the Earth, hot rock continued to swirl about, moving the crust from below and breaking it apart. This process is called plate tectonics, and is happening right now.
So I think we lot of understanding. We already have a lot of understanding how the plate tectonics ideas developed, right? So you know the plate tectonics ideas and the drift model. You remember? So before the Wagner, he just told us, okay, the Earth was many years ago, 1,000 years ago, it was just one piece of land, right? And then later we understand, okay, so they have a different plate tectonics, and each continent have a different plate, right? So keep enjoying the video, please.
We'll make a whole video about it in the future. For now, let's just say that the crust of Earth consists of separate giant plates that move around. As they meet, they crumble and create mighty mountains, or violently plunge back down deeper into Earth, creating deep trenches. That's the way the highest place on Earth was formed, Mount Everest, and the deepest, the Mariana Trench. From our perspective, Earth's mountains and trenches are mighty indeed, but when you look at the Earth in cross-section, you can see how tiny they actually are. The part you stand on is the crust, which is about 50 kilometers thick, though it can vary between 5.
So I think we already know this, the different parts of the Earth, right? So we know there are the three basic compositions or basic structure of the Earth, right? So you can see the thickness of the crust here, and then the rest of you will continuously see, right? So you see this is the ocean, right? So we can say this is the ocean crust, right? And then there's a different mountains, and we can say, okay, this is over the normal crust, right?
From 70 kilometers. By the way, the deepest hole ever drilled by man is 12.262 kilometers deep.
So you see, how deep is this borehole? Just 12.3 kilometers. It looks like a small dent on the Earth, right? It's just a small dent on the Earth. 12.3 kilometers. It's very small. Okay.
After the crust comes the mantle. It's a silicate rocky shell and about 2,900 kilometers thick.
So in my previous lecture, you remember that we have learned about the different, I give you the example about the apple, remember? So the apple has just, the outer skin, right? And then the earth is covered inside. Or you can also compare with the best example is like egg, right? You can also compare the example of egg. Egg has the outside is a shell, white shell, right? And then the inside is a white, right? And then there's a yolk, right? So you see, this egg can also explain the Earth's structure. So because Earth's structure is divided into 3 parts, so the same stuff we have here. Please keep watching.
Mantle consists of the upper mantle and the lower mantle. The upper mantle has different regions too. Its upper part, which is viscous and carries the crust, is called the lithosphere. After that, there comes the asthenosphere, which consists of less mobile, mostly solid material. The lower mantle reaches deep down to the outer core of Earth. Earth's outer core is a liquid layer of iron and nickel, about 2,266 kilometers thick.
So we already understand the core, how the core formed by, right? What is the basic material of the core, right? So this is, you see here, there are different compositions of the Earth and the different parts of the Earth. They are just this video actually is telling you, is revising your whole lecture today, whatever you have learned from me from the different slides. But this video is combining all them together, and you can learn some even advanced words. But I don't want to speak any word which is not right here. Okay. Yeah.
Temperatures vary from 4,000 degrees Celsius to 5,700 degrees Celsius. And in the center is the inner core. It's mostly solid, a ball made of an iron-nickel alloy with a radius of about 1,200 kilometers, 70% the size of the moon, and about the temperature of the surface of the sun. It is slowly growing at an estimated rate of about 1 millimeter per year. Now for some perspective. This small layer of crystallized milk products of former molten metal is where we live. Then there's Earth's magnetic field. It's an invisible phenomenon that diverts high-energy particles coming from the sun and other sources, allowing for a stable environment with comparatively little radiation impact on Earth. But why is it there? Actually, we don't really know a terrible lot about that. We know it has something to do with the core of the Earth. Inside this metal sphere, large electrical currents flow in complicated patterns. They cause a magnetic field.
So, the core actually, the core, inside core, right? Very, very hot, right? So you already know the temperature of the inner core and the outer core, right? So actually, in this core, there are a lot of processes are going on. Then the magnetic field, the magnetic field are producing inside the Earth, right? Okay, keep watching. You will understand this everything because the subtitles are in Chinese. I also put there, and also the English one, so you can also listen and understand the Chinese as well.
Field that sort of stabilizes itself according to the laws of electrodynamics. This entire system is called the dynamo. But don't let us fool you into thinking we have it all figured out. Speaking of breathtaking information, what about the airy stuff that surrounds us? By volume, dry air consists mostly of nitrogen, oxygen, argon, carbon, a variable amount of water vapor, and small amounts of other gases. Humans are very dependent on the lowest layer of the atmosphere, the troposphere, where the weather is. It's 12 kilometers thick on average. Above that is the stratosphere, which is where the ozone layer protects us from the sun's most aggressive type of light. Above that is the mesosphere, the coolest place on Earth, with an average temperature around -85 degrees Celsius. At about 80 kilometers up, the thermosphere starts. The transition to space is a fluid one without clear borders, but humans decided that space starts here. At about 100 kilometers, Earth stops and space begins. Though the atmosphere extends a bit further. In this region we find the ionosphere, the aurora borealis, and the ISS. And the outermost layer is the exosphere, stretching up to 10,000 kilometers. It merges fluently with outer space, where there's no atmosphere at all. The atoms and molecules in this area are so far apart that they can travel hundreds of kilometers without colliding with each other. Okay, humans in their present form have only been around for 200,000 years.
So now I think we can understand how the Earth is born, how the life is begun, right? So this is all about Earth history, right? So, at the beginning of this lecture, we actually don't know about the Earth. So, I asked the question, what do we know about the Earth, right? So, maybe we don't know at that time too much, but I think now you guys know a lot about this, how the Earth and what is the composition of this Earth, and right, and the different ideas, right? Let's keep watch this, please.
That's 0.004% of Earth's history. Not long, really. And here we are now, living in a thin, moist layer on a small, wet rock. We call this rock Earth. It is the product of the universe's deepest workings, the result of a constant process of creation and destruction, happening all over the universe all the time, helped by chance, the laws of the universe, and random events. We are really lucky.
And credit goes to the picture. They made a nice video. Okay, so I think back to the slides. So there are still a few slides left, and it's going to be finished. Okay, so I think this slide we have already done. You need to do activity, and you need to find out some reference books, and then you have to present your findings. I think you all already understand a lot of the Earth's history, the birth of the Earth, right, and the composition of the Earth. Okay, then go to the final slide. Let's talk about the summary. Okay, so the summary is very clear. So the Earth is made up of the core, the mantle, and the crust. I think for each part we have understand their composition, their structure, their length, right, and their all other stuff. Okay, now let's talk about the Earth is more than actually the age of the Earth. We also know how to measure the age of the Earth, right? So scientists have tried a lot to measure the age of the Earth. So the Earth is, we know that the Earth is more than 4.28 billion years old, right? But you remember before people they think that, okay, they just thought that, okay, this Earth is maybe 1,000 years old or a few years old, but it's not like that, right? But the ideas have changed with respect to the time. But almost we know that there are different tectonic plates, and how the Wegener's theory was wrong, and the people didn't trust him at all. Okay, so the surface of the Earth is made up of the tectonic plates, which move slowly. I think you have already watched a very nice video which tells you how the tectonic plates over the time. You remember that was 540 million years ago. Actually, that video is just a start from the today to up to the until 540 years ago videos. Sorry, 540 years ago history of the Earth, how the tectonic plates are moved slowly. Okay. And then scientists have studied the rocks and the meteors to work out the age of the Earth. Okay, so we also know that different meteors that is in the Canada, or sorry, in the Arizona, right, in the Arizona, USA, which fall from the sky, right. So the scientists also can compare their age with the Earth age, because we know that both are at the same time when the planet system was formed. Okay, we still have a last slide about the questions. The questions given, some of the questions are given in your textbook, right? So I think we can take a look on the questions quickly. So I think now you are able to understand and answer these questions. So here the first question is, what is the scientific name of the area at the center of the Earth, right? So we already know that, right? We have already studied very well in the previous slides. And which metals are found in this area, right? We already discussed all the metals, different metals we have already discussed, and what kind of area, right? We know that Earth has 3 areas, 3 different compositions, right? So 3 different layers, distinctive layers, right? And each layer has their own composition, okay? And then we also know what kind of evidence Wegener have for this idea for the continental drift, right? We remember we have studied the continental drift problem already, right? And we have answer for this also. I think you can also answer this question. It's pretty easy. All these questions. Why did some people reject his idea? You remember the people I discussed a lot there. Why the people reject his idea at that time, and because he was presenting his research to the scientist. You know, he's a scientist, so he was presenting his research, but the scientist wasn't believing him at that time. Okay, which plate do you leave on? You remember there are different plates are existing, like a Eurasian plate. So actually I am living on the Eurasian plate, and the same. Okay, so I already discussed that which plate we are living, like the Eurasian plate, right? And then this is the last question: what is the connection between the plate boundaries and where earthquake and volcano occurs? Remember, we have taken a look on very nice flash player. Actually, we saw there. We have seen different volcanoes and the earthquake zones and also the other boundaries. Okay, so just goes to the question and comments. If you have any question or comments, just you can send me email or whatever you like, or you visit my office. Thanks, sir.